Hello. In this video, we will cover techniques in dynamic programming, which is a paper I wrote for my analysis of algorithms class. And in this video, we will cover certain techniques and common problems, especially the knapsack problem in dynamic programming and some solutions to this problem. We will also cover the effectiveness of these solutions, and we will cover the some alternative solutions in dynamic programming and the effectiveness of those solutions as well, and the implementations in Python. In dynamic programming is particularly effective for certain optimization problems that have two key characteristics. This is the key part of what Richard Bellman stated originally in his first definition of dynamic programming and its use cases. The optimal solution to the problem that is solved with dynamic programming can be constructed from optimal solutions to its subproblems, and the same subproblems are solved repeatedly. The steps to a dynamic programming solution are as follows. The first step is to analyze this problem and determine if it exhibits optimal substructure and overlapping subproblems, as we discussed earlier. The second step is to determine the parameters that uniquely define a subproblem. The third step is to express the solution to a subproblem in terms of solutions to smaller subproblems. And the fourth step is to decide which solutions to pursue: memoization, which we'll get to later, or tabulation, which is bottom up, and we will get to that later as well. But there's technically other solutions as well, which we'll get to later as well. And then you implement the solution. Now, common solution techniques for dynamic programming are memoization and tabulation. The way you recognize whether it's memoization or tabulation is pretty easy. Memoization essentially is if it's recursive and if it's a top-down approach, then it's memoization. If it's a tabulation, you have to build up a 2D table, then it's probably going to be tabulation. That's how you can tell the difference between these two patterns, these two approaches. On page 3 of my paper, you will find some alternative solutions which are actually not done with memoization or tabulation. There is Fibonacci sequence solution, which is done with iterative programming. There is the traveling salesman problem, which uses bit masking, but at its core, it is still tabulative. And now we are getting into the classic dynamic programmings, and there is also the knapsack problem, and there is longest common subsequence problem. Now, the longest common subsequence problem, this is actually, I believe, this is tabulative. This is done with tabulation because, as you can see, there is a 2D list involved. So this is done with tabulation. This is done by filling out a table. This is how you get to the solution here. So this is done with tabulation. But the knapsack problem can be done with either tabulation or memoization. We get to the knapsack problem, I think, by page 5. So page 5, there's introduction to the knapsack problem in dynamic programming, and in page 5 we discuss the knapsack problem. We discuss the introduction to it, what it is, how it's done. There's also introduction to the non-dynamic approach to the knapsack problem, such as the greedy algorithm. Then on page 6, I go over the dynamic programming approach to the knapsack problem. So first, there's the memoization solution in Python. Then there is the tabulation solution in Python. And after that, I compare which solution is more efficient. I think this is page 7. And here I did some unit testing for these solutions on page 8. You can see small data sets. Small data set, both of them were pretty much 0 seconds. It took pretty much 0 seconds for memoization and tabulation to run. But for what's interesting, for many items, for the test case with many items, memoization was much, much slower than tabulation. So tabulation performed much better with unit testing with many items. And with large capacity, it was the opposite case. Large capacity tabulation performed much poorer. So the conclusion I've drawn from that is that tabulation is more efficient when there are many items but the capacity is low, and theoretically memoization would be ideal for a problem with limited solution space, which means a small set of subproblems need to be computed. So it makes sense that it performs relatively poorer with large data sets. Then page 9 is historical figures in dynamic programming and optimization. All these people contributed pretty greatly to the field of dynamic programming, especially the person on the left here. That's Richard Bellman. And finally, the conclusion on page 10 and the sources on page 11 in APA format. So that's pretty much it. For people watching on YouTube, because I do have a large following on YouTube, the paper will be linked in Google Drive.